It's GFG daily problem burst pattern. This is a pretty famous DP question, right? And as some guys have told me before that you should do more DP questions. So yeah, here we are. But yeah, that's a daily problem of GFG. You have been given n balloons, 0 to n minus 1. Each balloon is painted with a number represented in an array. So basically, this is what the balloons are like, and each number denotes a particular balloon. You are asked to burst those balloons. You have to burst all balloons, right? If you choose to burst, let's say, ith balloon, right? For example, if you choose to burst this first balloon with the color 1, what will you get? You will get some coins, money, or you can, you will get some profit. Basically, that is basically this, that many coins. Okay, here see. So this is area of I minus 1, yani ki this is like 3, and area of I is 1, area of I plus 1 is 5, right? So you will get these many coins after bursting 1. So you have to tell, uh, yeah, if this I minus 1 or I plus 1 goes out of the bound, you have to take 1. So what we can do, we can insert 1 or 1 at the end and at the beginning of the array. So then you don't need to, yeah, take care for that, or otherwise you can specifically take care for the particular indexes, right? Yeah, that's about it. And return the maximum number of coins that you can get by bursting balloon. Okay, so why this question is, I said DP problem, because here the whole answer depends on your way of bursting the balloon, your pattern, your order of bursting the balloon, because you have to burst all the balloons in. Then it's not like you will first balloon 3, you then 1, then 5, then 8. The answer which you will get maybe or may not be maximum, but the maximum answer you will get key first after bursting the balloon 1, let's say, yeah, and then after balloon bursting something like 5, then after bursting 3, and then after bursting 8. So 1 5 3 8, this is basically a good pattern. If you burst in this pattern, the answer is going to be maximum. So this is like partitioning problem, or basically some that kind of problem where you have to find a particular pattern in which you have to yeah, take all the elements, but there has to be an order, which order gives you the maximum answer. For example, like order in case of indexing, yeah. So if this is like that, and indexing are something like this: 0 indexing, 1 indexing, 2 indexing, 3 indexing, yeah. So what you the good order is 1, then let's take 2, then let's take 0, and then let's take 3, yeah. This is the best possible order. The answer which you'll get, yeah, is 167. That is a maximum. So yeah, that's about it. Now the logic behind this problem, like the DP logic is key. See, for every particular element, what if I like burst this in the last, what will be the answer if I burst this balloon in the last? For example, what will happen if I burst a three balloon balloon with a value 3 at the last? So you will first calculate, I'll answer for 158, because these you have already burst in some order, you never know like in which order, but these balloons are burst. And over here there is this thing, but there's nothing on the left side, but we'll take one, as they say. So we'll say, okay, the answer for this would be, let's say, x. Then the answer for bursting that last balloon would be x into 1 into 3, something like that. And previous answer to हमारा x था ही, वो तो रहेगा ही, right? So that's about it, like we have to do. But how we will gonna proceed it, basically we are gonna yeah, we are gonna checking each sub array, basically for each sub array, because this is a complete array. And we are gonna make a dp of 2d dp int dp of something like let's say vector of vector int dp of n comma vector of int dp vector, right? So yeah, that's about it. This is our DP, and at last we will be giving the answer from return of the whole answer for this whole array, 0 to n minus 1. But in the while forming this, like we will form this by using the middle, sub arrays, like all the sub array present in this. So there are two ways of getting a sub array. You can do directly two for loops for starting and ending index, or you can do one loop for length and then specify your starting and ending index. Not like this, but something like this. If I is equal to your 0 and j is equal to your this length, right? Or let's say length minus 1, because length can go to from 1 to n, and length minus 1. While j is less than n, I'll go I plus plus as well as j plus plus. I plus plus and j plus plus. So this is basically generating all possible subarrays. Yeah, all possible subarray in such a way that smallest subarray is checked first. So first I will check all the subarrays of length 1. then length 2, then length 3, then length n. For length n, there is only one subarray, right? Hmm. That's getting calculated in the last one. That's the answer. Now basically a partitioning DP वाला concept लग जाएगा. If you are dealing with a sub array of I to j और आपको इसको you have to like break into three pieces. So basically you will decide some k and you will calculate the answer for I into k and then k into j. Basically now you are bursting, you are saying कि this is the I comma I to j वाला sub array. I want to burst these sub array balloons. But लास्ट में मैं क्या बर्स्ट कर रहा हूँ, लास्ट में मैं k बर्स्ट कर रहा हूँ. So अगर मैं लास्ट में k बर्स्ट कर रहा हूँ, so it'll give me the value of I minus 1 to k and then k to j minus 1. So first of all let's start here. int k is equal to I से start होगा, k less than equal to j तक जाएगा and k plus plus, right? Then I'll get the answer of, I need two three things, like I need left basically is the, it's not the left answer, it's the value present at the left, which I need for this operation, like array I minus 1 j minus 1 plus e, right? So I'll say nums of k, not k, but I minus 1, right? Nums of I minus 1, because maybe like this you can only say over here, not like this, because left and right some things are like irrespective what is your k is, this L would be something like what is I minus 1. This R would be something like what is J plus 1, right? But I minus 1 you can only calculate when I is greater than 0. And if I is greater than 0, then you can calculate this. Otherwise, the answer for this would be not 0 but 1. Yeah. If there is nothing, you have to take 1. That's they say. And let's talk about R is equal to if your nums of J plus 1. But it's not guaranteed that J is less than N. So if J is less than N minus 1, then you can do this. Otherwise, you will just say, okay, it's 1, right? So that's about your L and R. And now if you have this J, you will get, you can say this is, you will get left answer or right answer. Basically I to j, I to k wala answer, give any name. I'm just giving a, and answer for dp or I से लेके k minus 1 तक का आंसर, because k वाले को अभी हम डील करेंगे. But this is the thing, और इस yes में ये होना चाहिए कि if I should not be equal to k. So if I is equal to k, then we'll just take, I think, what we'll take, we'll take 1 now. No, no, I think we should take 0 in this case. If I is equal to k, then 0, otherwise this. And similarly, b is equal to your dp, whatever is from j to k. And then j, not j to k, but k plus 1 to j. This was k minus 1, then k plus 1 to j. And this maybe we have to ask if j is equal to k, then you have to say 0, otherwise this part, right? What I'm doing, k plus 1 to j. Yeah, that's about it. After this you can just say dp of I to j का answer जो होगा, like how we do in partitioning, which partition is the best partition. Take max of dp of I to j comma the partition value if you partition around k. So that would be something like what is the partition value. Now you have to use this thing कि एक तो होगा कि तुम्हारा LR होगा into सबसे पहले you will be getting something like कि आपने left part फोड़ा है तो उसका क्या आंसर है, right? A क्या है, आपका B क्या है, प्लस आपको इस पार्ट को फोड़ने से कितना आंसर मिलने वाला है, which is L into something like nums of I, not nums of I, nums of K, because you're yeah, you are bursting the kth balloon. L and R, something like that. I think yeah, that should be fine. Let's try some. Okay, I think N, and over here I should do it what? Nums. I plus plus is equal to L minus 1. Okay, fine. Let's try to sum it. Oh, nice. Like in one attempt only. Okay, guys. So that's about it. But yeah, it's kind of a standard problem, DP problem. You have to practice DP, then you should do this question. Burst balloon is one of its kind. Like partitioning DP का एक सब टाइप है. Basically partitioning DP के काफी क्वेश्चन बनते हैं. Partition DP का स्टैंडर्ड फॉर्मेट होता है. We take the sub arrays and sub array को dividing point देखते हैं हम. Like एक k point होता है जिससे हम around हम divide करते हैं. कंडीशन क्या चेंज होती है बार बार, ये कंडीशन चेंज हो सकती है. लाइक दिस, इन दिस केस वॉट एवर द वैल्यू यू आर गेटिंग इज दिस वैल्यू. कई बार लाइक द अदर थिंग विच यू गेट, बट यू हैव टू कैलकुलेट आंसर फॉर द लेफ्ट पार्ट. लाइक दिस a is answer for I to k minus 1, k to j, k plus 1 to j, you have to calculate. And yeah, this is basically according to the problem left and right part, which you need to adjust basically this multiplication you are getting as coins as amount. So you have to maximize it basically dp of ij around every partitioning point, and at last you have to return answer for 0 to n minus 1. Okay guys, that's about it. Bye.